So say we have the number 2,842 in decimal and we want to go to hexadecimal. So we're going to have to do that the same way that we did binary. So you know what though? I have a little problem with not being able to divide by 16 at the top of my head. Now for the test, for the AP, if you're taking the AP, you won't get a calculator. But for this, we're going to use one because we're going to have to do that the same way we did with binary. So divide that by 16. So 2,842 divided by 16, which gives us 177 with a remainder of, now if you don't remember how to calculate remainders, just do 177 times 16, and we're going to subtract 2,842 from that. So remainder of 10, which remember isn't 10, it's remainder A. Oh yeah, we get to use hexadecimal right away. 177 divided by 16 is going to give us 11, remainder 1. And 11 divided by 16 is going to give us 0 with a remainder of B. So remember 11 is B in hexadecimal. So we read bottom to top. So our answer is B1A. So it's the exact same process, just a few more additions of having to remember that once you get over 9, it's letters, and dividing by 16 is a little bit harder to do in your head than dividing by 2. Now this is the only example I'm going to do of converting decimal to hexadecimal, just because it's the exact same process. So if you are confused, if you are stuck, shoot me an email. I'm happy to make a couple additional help videos with this. So the last thing we're going to talk about is octal. So first off, we're going to talk about converting from octal to decimal. So say you have the number 43 and it's octal, and you need to go to decimal. So just like with the other ones, this is 8 to the 0 spot, this is 8 to the 1 spot, and if it was any larger, it would go further and further. So this is 4 times 8, and this is 3 times 1. So we're getting 12, nope, 4 times 8 is not 12, 4 times 8 is 32, plus 3 is going to give us 32, plus 3, which is 35, and that's decimal. If you had like 1025, I'm going to put that in a box because it's a little easier with these larger numbers like that. So this would be 8 to the 0 power, which is 1, 8 to the 1 power, which is 8, 8 squared, which is 64, and 8 to the 3rd power, which is 512. So we have 1 512, we have 0 64s, we have 2 8s, so that's 16, and we have 5 1s, which is 5. So we do 512 plus 16 plus 5. So this would be 528 plus 5, which is 533 in decimal. And for our last trick, we're going to turn 2,111 in decimal all the way to octal. So again, we set this up, divide it by 8. So you can use your calculator for this, which is 263, which is remainder 7. Divide this by 8, which is 32, which is remainder 7. 32 divided by 8 is 4 with a remainder of 0. And 4 divided by 8 is 0 with a remainder of 4. So you read up. So 2,111 in octal is 4,077. The last thing I want to talk to you guys about is actually using binary, octal, and hexadecimal in Java, because that's the whole point of this class. So if you go to page 6970 in your book, there's some examples of that. So if you want a binary number, the code that you would put in front of it is 0B. So the example would be like int x equals 0b10110. Because otherwise, it would automatically think that this is a decimal number and that it would be 10,110. So to force it to be binary, you put that 0b in the front and it will be able to tell the difference. So if you want octal, the code that you use is 0. So if you put in int x equals 0734, it knows that 734 is the octal number. If you are putting a number in decimal, you just keep it the same. And if you are doing it in hexadecimal, you put 0x in front of it, like int x equals 0x4cb3. Now, if you want to convert bases in Java, you are going to use a certain code. There's actually a couple different codes, but I'm just going to teach you the one. So like if you had int x equals 54, and you want to print it in binary, you would do system.out.println, and it would be integer, capital I, dot to string. You're actually convert to a string. Say x because that's the number you're using, comma, whatever base you want to put it in. So if you do 16, that's hexadecimal. Okay, if you did it the same way, but you did it to base 2, it's going to put it in binary. And if you do it in base 8, it's going to do it in octal. And actually, these are the only ones we're really talking about, but you can convert to other bases as well. They do exist. So the easiest way for you to remember it is just do like string s is equal to integer to string, whatever the number, the integer you're doing is, comma b for base. So that's just the basic skeleton right there. For lesson 14, you do have a project that you're going to have to convert between bases on. So you're going to have to use tab and you're going to be using a for loop. So this is really going to tie some stuff together for you. So please let me know if you run into any problems or if you have any questions. Good luck.